Hello, my name is Roman Harkovsky. In this demonstration, I'll show you how WebSphere Application Server Network Deployment 8553 handles heavy workloads in unpredictable environments using Dynamic Cluster Facility. What I have in my configuration is a VMware workstation running 5 virtual guests, all running in Linux. All of this is running in a Windows environment on a laptop. This is ThinkPad W530 laptop. Let me explain my configuration. What I have set up in this demonstration is a client machine that runs the HTTP workload. So the client generates HTTP traffic into what we call on-demand router in WebSphere. It's ODR. ODR is a Java process. It can run standalone, or ODR can run as a plugin in HTTP server. ODR does workload management across multiple WebSphere nodes. In my case, I only set up 3 WebSphere nodes. Each node would usually be a separate machine, or it could be a virtual guest. In my case, they all happen to run on the same physical machine, all 5 of these. And the WebSphere cell includes all of these WebSphere instances. Every node can run multiple JVMs, and these could be application JVMs and also node agents, deployment manager, and dynamically WebSphere will decide where to stop and start which JVM depending on the workload and depending on the relative importance of the application. So this is all was in D cell, and ODR gets automatic updates on the response times, on the traffic, on priorities of the application, and it queues up client workload. Okay, so let me show you how dynamic clustering stops and starts servers automatically. So let me start the test. So first of all, initial state that I have defined is that all of the hosts are idle. There is nothing going on in the system, and the client host, where I logged from the client host into the deployment manager, and you can see that all of the instances of my dynamic clusters are shut down. So let me see if my applications run. I will have 503 for all of these instances because all of the servers are shut down. Now what's going to happen when I do this, the on-demand router, which runs in this host, will pick up the request, HTTP request, and it will determine that there is no suitable JVM running, so it will go ahead and start the JVM. So eventually the JVMs are now started. So you could see that disaster response application was started on host 1, and other applications will be started shortly. Now if I refresh the status, then you can see disaster response application is already up and running, and imagine other servers. So host 2 is starting a JVM, and host 3 is starting a JVM. So let's make sure that those applications work. Alright, we'll get that shortly. So let's do the very basic load test. So let's run 5 requests for each application type, and as soon as the servers are started, alright, so we have tax payments application and we have the driver's license application, so they're all up and running. So let's go ahead and start the basic test with the JMeter, and what you can see is, let me clean up the statistics. So after I clean up statistics, then you can see average response time when running 5 concurrent users is roughly about 50 milliseconds. And remember, I have 20 millisecond sleep time inside of the server application, and every time I call that application it has 100,000 loops running. So that's inside of the server. The servlet itself executes that. And again, 5 concurrent threads for each. So we're running, no errors, and you can see the throughput. Roughly we get 300 requests per second, again considering 20 millisecond sleep time and 5 concurrent threads. So that's what we get with a very low load on the system. And if I refresh my servers, then you will see one instance of disaster response application, one instance of the driver's license application, one instance of the tax payment application, and they all started on separate nodes. So this one was automatically started on host 3. Now the process of starting the first instance is called a lazy start. And if I go into my dynamic clusters, you could see I defined those clusters as automatic. And if I go, for instance, into the driver's license application, then I have those properties, and I can also go into custom properties, and you can see there is a proactive idle stop, which is true. So what that means is when there is no load on the system, WebSphere will automatically shut down all of the JVMs after a certain period of inactivity, and that period of inactivity is defined right here, where I said after 1 minute of no requests, please shut down all of the instances of my servers. Now if I don't define that custom property, then what you will see is the servers keep running unless there is a very critical load on the system and memory restrictions, in which case those instances will be shut down. So going back, and let's reset the statistics again. So we see different response times for our applications, and you could see that response time for disaster response application a little bit faster. Second fastest is a tax payment application. Third fastest is a driver's license application. And again, this is because of the service policies that we have defined. So the service policies I defined are here in the service policies, and I set my bronze policy as the lowest priority, and I set the goal of that as discretionary. The medium priority is the silver policy, and average response time for the silver policy is 3 seconds. And the highest priority is a gold policy, which I defined as 100 milliseconds. Now I can create a new policy if I want. I can call it a purple or pink policy or whatever I want, and I can define the goal time, for instance average response time, and I can say that would be response time in seconds or milliseconds, and I could say whatever I want, 600 seconds or milliseconds. And again, I can define the relative priority for my goal. So far I'll just stick with my silver, gold, but I can call them anything. They should be meaningful names. Now in terms of the mapping of my service policies, so you could see the gold policy is mapped to my disaster response application, which I have 2 versions of that. Silver policy is mapped to the tax payment application, and the thought process is I need to respond to disaster requests quickly. Tax payment also has some priority because I need to file the taxes quickly, and driver's license application could wait because that's not urgent. That's why I defined that as a bronze policy. So going back and looking at our statistics again, you could see that we're not violating any of the service policies at this time. Even though there is some priority given to the disaster response application, it runs a little bit faster than others, even though there is the same amount of number of threads going in. Their prioritization is done across these requests. But we're not violating anything. In fact, if we look at the CPU, you could see that it settled down and it's quite low CPU usage. The host 1 has higher CPU usage because it also has deployment manager in addition to the actual application JVM. Now what happens if I increase the workload from 5 requests to something where I run out of the CPU capacity, so that my existing CPU and memory and network capacity is no longer able to satisfy all of my service level agreements at the same time, or maybe violate one of the service level agreements. So let's ramp it up to 90 concurrent threads for each of the types of servers. Now, and let's see how WebSphere reacts. So we'll shut down the workload and we will start the new workload. Let's reset the statistics. So now you can see we're violating, at the very least, the SLA policy for the disaster response application, because again, if you remember, looking at the service policy for the disaster response application, which is a gold policy, the response target is 100 milliseconds. And if we look at the application, the CPU usage, we're very close to max out the CPU usage on host 1, and we're close to, no, we're not using that much of a host 2 CPU yet, and we're very close to max out the host 3 CPU. Now, if we look at the servers that were started, and again, those were started automatically, so you could see that the WebSphere started driver's license server proactively, and once we let system run a little bit, you will see that it will start probably most of these servers that were created for us as part of dynamic clusters. And the reason the servers are being started is because we're violating SLAs. So if you look at the response average, then you could see again the disaster response application, it is still violating SLA, but it runs faster than two other applications. Tax payment application is not really violating SLA at this point, because our SLA is set for 3 seconds and we're 1.2 second average response time. And the driver's license application is discretionary policy, so it doesn't matter what the response is, it will be done on the best effort. We can look at different settings because I need to let the system run a little bit because it doesn't make immediate changes to the configuration. If we start stopping and starting servers immediately, the moment we got a increase in the workload, then stopping and starting itself will overload the system because it takes a little bit of CPU to stop or start the server for 20 seconds, 10 seconds. We're loading the server a lot, so if we start doing this knee-jerk reaction, we're doing more harm than good. That's why WebSphere has settings on how often to make these placement decisions. And here's the configuration for what we call application placement controller. So the application placement controller, it shows us different settings for manual mode, approval timeout when we're running a manual configuration, which I'm not doing at the moment. I'm using automatic configuration for the dynamic cluster. There's operation timeout for server stop and start events, and I've put placement change time interval as 1 minute. So what that means is after 1 minute and after a certain time of smoothing windows and period which I can configure in automatic request flow manager. So you could see there is a smoothing window and control cycle minimum, and I can define that in seconds, minutes, or hours. So the autonomic request flow manager together with the automatic placement controller, they will together make decisions about when to stop and start dynamic servers. This is based on the workload, it's based on service policy, on the goal of the service policy, like response time, or based on relative priorities of those requests. And in addition to SLA and making those JVM placement decisions and starting and stopping the servers, I can also configure memory protection. For example, I can say I want to do certain things when my heap size gets to whatever percentage of the JVM, and I can also do the CPU throttling. So the CPU throttling allows me to keep certain percentage of the CPU on the node available for administrative actions and other things. Otherwise, like this console would be extremely unresponsive if it goes into the server where I'm using 100% of my CPU. So let's go back to the JMeter and let's reset the statistics and see where we are in terms of the SLA and average response times. So we're still violating SLA and disaster response application, but we're doing fine with tax payment and driver's license. So what I expect to see, again, after some time passes, I expect to see WebSphere start additional JVMs for the disaster response application so that it will cut down average response time to something that we have defined in SLA, and also observe the SLAs for those other applications, and do that considering the relative priority of those applications. But again, this takes a little bit of time, and in production, again, you don't want to configure these things by the minute. It's probably several minutes, if not hours sometimes, depending on the size and complexity of the application that needs to be considered, and those, again, smoothing windows where you have to let it run for a little while. So let's have a look at what's going on as of now. So you could see that the JVMs for tax payment and driver's license have been started, and the disaster response, because it has the best response time so far, only has a single JVM started so far, but I expect that to be changed pretty soon. I expect the new JVMs for disaster response application to be started. Now, in the meantime, I want to highlight that the service level agreement could be configured not only at the granularity of the application itself, for example, not at the granularity of the WAR file or the EAR file. So if I go and look at my applications, for instance, disaster response application, then I can configure service level agreements for number of things and for very specific URL inside of that application, and we call it transaction classes. So that when I go into service policies for my application, I can configure, first of all, you could see there are work classes for HTTP, SOAP, IOP, and JMS requests. Now in my applications, I'm just using, as you can see, HTTP requests, and you can see that I already have second instance of disaster response started on host 2, which happened in the background. Now I can configure these work classes, and for now I have this wildcard, which means that all of the requests into this application, they map into my gold transaction class and gold policy. But what I can do, I can apply those classification rules, and these classification rules can have fairly sophisticated expressions. For example, I can say that based on virtual port, URL, user ID, group ID, roles, cookie, MIME type, HTTP method, IP address of the client or server host or port protocol, and some other things, percentage or time, I can define different routing for start time and end time. So I can define that at the different times of day the routing will be done differently, and prioritization of requests could be done differently. For example, group ID, I can say that for security realm where I have gold users, and that could be mapped into LDAP or security realm user class, I could say if the user class is gold, then this user class could be mapped into a special service policy. So for example, for the same application, different classes of requests for different users could have different priority. I could have gold users have higher response times, and like platinum card members have the highest platinum service policy, and the regular members have the lowest discretionary policy, for example. So this is quite flexible. So in the meantime, let's go check out what application servers have been started. So while I was talking, WebSphere has started additional instance of the disaster response application. So you can see we now have 2 JVMs for disaster response, we have 2 JVMs for the driver's license app, and have 3 JVMs for text payments. So let's see what is the average response rate we got so far. So let me reset the statistics and see the most recent numbers. So disaster response, so it's still violating SLA on average. Tax payment is under 3-second SLA goal, so we're good. And we're already maxed out because we run 3 JVMs. And again, all of this happened completely automatically. I didn't have to click and start any of these servers. But because we're violating SLA on disaster response application, I expect that WebSphere will start additional instance of disaster response application, in this case on host 3. So we'll need to give it a little more time. So I guess I need to keep talking to show you that WebSphere will start those instances. So let's have a look at the server use. So server number 3 is not very heavily utilized. Host 2 is roughly 83-90%, and server 1 above 90% average. And the on-demand router is not very busy in this case. So let's refresh the list of servers and see where we are. So what this is, it's a dashboard of, in my case, average queue lengths at the ODR. So you could see the queue lengths overall for on-demand router, the queue lengths, and you can see this yellow line at the top. So, and that shows me about 17-18 requests in queue at any given point of time. And you can see the queue lengths for different service policies, bronze, gold, and silver. And you can see gold, which is red, doesn't have any queue lengths at all. So those requests get dispatched immediately, where silver and bronze are kept in the queue of about 9 to 10 requests in the queue. Now you can add the data to this graph. So I can add the data about my on-demand router, number of concurrent requests or average throughput and other things. I can add data about my service policies, about my application, or other things. So there are number of different options that I can configure, and I can define for app server instances. I can see different statistics, concurrent requests, average throughput, again, goal rates, and number of interesting things that I can map and watch on this chart, and I can save it into configuration. Alright, so let's go into the list of servers and refresh the list and see what's going on. Right, it hasn't started additional instances yet, so let me reset the statistics to see the latest numbers. Alright, so disaster response app, we're getting closer to the target service level agreement of 100 millisecond. The tax payment is under SLA, which was 3 seconds. Disaster response is 60% over SLA, but you could see it is being prioritized over these other workloads. Now the other thing is there is a lazy start property on my servers, and if I stop the workload on one of these servers, then the JVMs will be automatically shut down to free up memory and CPU usage. I can also see in runtime operations, I could see the dashboard of what's going on, and in that dashboard I have an overview of the state of my servers, and you could see also the decisions on what needs to be started, where it had to be started. So these are basically some decisions about the placement of my servers, and here's the dashboard where I have average response times for my applications, service policies, and you can see average response time for my service policies. And you can also configure custom reports. So if you go into reports, which I've done on that other page, and you can add additional properties here. So you can add the data, and again you can see all of these different options, so you can monitor the environment from here. Now the other thing, I haven't shown you how to run these servers in supervised or manual mode, but if you run those servers in the supervised or manual mode, then what happens is you have these runtime tasks generated for you by the system. And these runtime tasks, for now you could see that when you run in automatic mode, there is no action available. It's just the system does start and stop instances for you automatically. It just tells you what was done and why it was done. But if you run in a supervised or manual mode, then you will be able to approve these things. For instance, it will say, I'm violating SLA for such and such application, and I feel like I need to start additional JVM on this host, please approve. And you can click and say, I approve. Alright, so let's see how we're doing. Let's reset the statistics. Disaster response application runs fastest. So we're still not meeting the SLA quite yet for disaster response application. Let's see what servers we have started. Okay, so it hasn't started the disaster response server. And by the way, I can certainly start and stop servers manually if I wanted to, but I don't have to. Now the difference is, if I was running this workloads in parallel on WebLogic or JBoss or Tomcat, I would pretty much have to start all of these servers up front. And the worst part is, if I have a workload on one server that has to consume resources on all of the other nodes, in case of JBoss and WebLogic and Tomcat, there is no automatic shutdown unless you write that script yourself and you completely automate and rebuild this kind of framework that we implemented in WebSphere. You could certainly do check on the response times and then start and stop servers through scripts, and that would be fairly sophisticated framework that has to be implemented. In WebSphere, this is all out of the box and it works most of the time anyway. And it's configurable, and there's monitoring and configuration. One other thing I didn't show yet, for applications, I can configure multiple versions of my applications, and there's Edition Control Center. I'm just killing time while the server runs my workload, and I have a dashboard of all of the versions of my applications, and I can sort them by the state, for instance. So you could see there are multiple versions of disaster response application. There's a base version, and there's a version 1.2 which is active, and I can start and stop this version, and I can also remove that, and I can take different actions on my applications. I can go into Edition Control Center, and I can configure what do I want to happen with my version. So for instance, when I go into the Edition Control Center and I go to Disaster Response Application, I can see there are two different editions. One of them is active, and when I click on the application, it will open and it will list all of the versions, and I could have many different versions listed here. And then I can select which version needs to be activated, deactivated, and I can do the rollout. So I can deploy the application, like new version of the application, but I don't have to roll it out, and I don't have to uninstall the previous version of the application. So if something goes wrong with my active version of the application, I can go back to the previous version in the console. I can also run it in a validation mode where only certain people will be able to access that application, and so forth. But overall, you can see we're definitely prioritizing the responses for disaster app. The tax payment application is second in priority, and the driver's license app is third in priority. So let me pause the recording a little bit, and I'll let it run for a few more minutes so that eventually the system will decide that it does need to start an instance of the disaster response application so that we meet the SLA level. Okay, after a few minutes, WebSphere finally decided that it's now time to start a third instance of the disaster response application. And let's reset the statistics and let's see where we are. So I think the server is still being started, so we're still a little bit above SLA. Let's see, the host CPU usage is pretty high on all three of these machines, and you can see the status of the server. So the third JVM is now started on this machine. By the way, if we go into the clusters, and you can see for now we have automatically defined for us one JVM instance per node in the WebSphere configuration. So what that means, 3 applications, 3 nodes, total of 9 server instances for those dynamic clusters. But if I go into my dynamic cluster, for the cluster I can change the configuration of the cluster so that I can say I want to use vertical stacking. What that means is I could say I want to have 2 instances on the same node, or 4 instances, or 5. If I have a really big node with multiple CPUs on that node, there's a possibility that I will get better performance. Maybe my resources are IO bound and require a lot of backend databases, or whatever it is. Maybe they're not scalable. Maybe I wrote my application code in a way that it is single threaded and I can't really get the scalability from a single JVM. In this case, starting multiple JVMs might be useful. So I can say I want to use 2 JVMs per node for this cluster, and when I save it I click OK. Another thing, when I keep adding new nodes into WebSphere cell, depending on how I define my dynamic cluster, WebSphere will automatically create new instances, again new definitions on those nodes. So I don't have to go and manually do that. The whole fact that I'm using dynamic clusters allows me to do that automatically. Let's see where we are in terms of the service level agreement, and you can see the SLA of 100 millisecond for this highest priority application is almost met. The SLA for tax payment application is definitely met because we're way under 3-second response time, and the driver license application was discretionary, so we're doing fine. Alright, let's save the configuration. Let's see the definition of our servers, and now you can see that WebSphere has created a second instance of JVM. It did not start that, but it created the second potential instance on all of those nodes where we could have that. Now if I go into my dynamic clusters and I click on my disaster response, and I say that I don't want to allow multiple instances on the same node, and I click OK again, then those definitions of potential JVMs will be automatically removed. So that's the beauty of dynamic clusters. You can define the membership in those dynamic clusters based on certain criteria, host name and so forth, so it's automatically creating those JVMs, and based on the workload it is starting and stopping those JVMs on the same node or multiple nodes. So WebSphere takes care of that, and it defines where to start the optimal number of JVMs. So you could see those extra JVMs that were configured, they disappeared. Okay, so now let's look at our CPU usage. Let's reset the statistics and let's see where we are. Okay, so again you could see that WebSphere is doing its best to meet service level agreement. Now one thing to keep in mind is the fact that if you have more workload than your server can handle. There is no magic. WebSphere cannot just automatically come up with extra CPUs. So it does relative request prioritization, where you can see in this case, but it can't meet all of the SLAs at the same time. It will do its best, but you have to define those SLAs, and they have to be reasonable. For instance, if I go and I say instead of 90 requests per second, use 80 requests per second for all of these JVMs. By the way, we could say for driver license application, let's disable that at all. So we're gonna have no requests at all to that application. So we'll shut down the test and we'll restart it again. So what you will see is, because I configured lazy application start for the driver's license application, let's reset statistics. After a little bit of time, all of the instances of the driver's license application, they will disappear because I'm not using them. So WebSphere will free up memory and CPU cycles by shutting down these instances. Again, it's not done instantaneously. It's done after a certain period of time. So let's do 150 threads for tax payment application. So now you can see that we have enough compute resources. So for disaster response application, we're pretty much meeting the SLA more or less. Now let's see where we stand in terms of the number of JVMs started. So for the driver's license application, I expect these started instances to disappear because, again, for the dynamic cluster, driver's license application, for my dynamic cluster, I did configure lazy application start. I said if other dynamic clusters need resources, stop all instances, wait 1 minute before stopping. So that's one thing. And another thing is, in custom properties, I defined this property, proactive idle stop. So it's basically, it's not gonna wait until I need that space. It will just see that there are no requests for that application, and it will just stop it if we're running. So you see one instance of the driver's license application was already shut down, and I would expect that this one last standing instance will also be shut down automatically because there are no user requests to this application. So all I need to do is just check that, yeah, we're only running load on the disaster response application and the tax payment application. We're not loading the driver's license app. So let's refresh, and let's see when this instance of the application goes away. And once it goes away, I will start the workload, and then you will see how WebSphere automatically starts it up. Now, what is the benefit of all this dynamic clustering? If you're running with JBoss or WebLogic, you'd have to have one of two things. One, you'd have to recreate this dynamic clustering framework yourself. Just write a bunch of Java code or some scripts where you will monitor requests, read JMX data on running applications and status of servers, and completely automate all of these procedures of stopping and starting servers, creating new servers. That will be a lot of programming, a lot of debugging, a lot of support for that, and it's not trivial to do this kind of stuff. WebSphere provides this out of the box. With JBoss WebLogic, you'd have to build that yourself, and that's several very, very skilled programmers for a very extensive period of time. So I would expect it's gonna take maybe 10 people over a year or a couple of years to build this framework, if not more. Plus you need to build the monitoring user interface and all of this stuff, and debug it and maintain it. It's not exactly easy or trivial to build this functionality, but that's an option. It could be done. Anything could be done. Another option is that you will have a live human beings monitoring your application performance through the dashboard. You'd have to have those live human beings just watching the workload and stopping and starting servers, and you would have to create the big cluster in advance and it has to be big enough to accommodate the workload. You'll have to manually look at all of these requests, figure out what needs to be started and where. That's not trivial, and humans make errors, so they might be stopping or starting things they don't need to be stopped or started, and there could be typos, and it's expensive to keep those people on staff because they need to be glued to the monitor, and it's a really boring job to do this. It's much better to have it automated, and because humans can't react that quickly to changes in the workload, you will probably have some customer satisfaction issues. As you probably know, every second of additional server response time counts for 7% conversion rate. So you might have customer satisfaction issues, potential loss of revenue, SLA payments, whatever it is. So it's going to be costing your business some money. And see where we are. Alright, so let's see where we stand with. Alright, so now you can see the instance of the driver's license application is in the process of being shut down because nobody is using that. So it's partial stop on node 2. When I refresh again, you'll see driver's license application is completely shut down. Now if I go into the disaster response application, you can see the responses are coming from all 3 servers, and WebSphere is configuring the dynamic workload. So if I go into my dynamic clusters for my disaster response application, you will see that WebSphere calculates the load factor. You could see all of the servers that are being part of that cluster, and here's a manual dynamic workload. There's also runtime weight that is being calculated automatically, and all of these they change on the fly. This was the overview of WebSphere dynamic clustering. I hope you found this useful. Thank you very much.